Lección 3.2. Today, what we're going to be talking about is adding and subtracting with decimals, alright? So you've already learned how to estimate calculations with whole numbers and calculations with decimals. But today what we're going to learn is how to add and subtract with whole numbers and decimals. So we're going to get more exact. So last class we talked about estimating. Today we're going to be talking about being exact and how to add and subtract decimals. So before we get started, what I want you to think is, have you ever seen someone design or construct a building? Alright, when would be a time that they might need to do something like this of adding and subtracting decimals? Alright, well maybe if they're wanting to get an exact measurement, right? If we were constructing something like a house and we needed a certain wall to be 12.4 feet long, right? And then it was meeting up with a wall that was going to be 13.6 feet long, right? We need them to match up exactly. We're going to have gaps in our house. The house is going to fall down. There's going to be air coming through. Animals are going to get into it if there's too big a gap, right? So we need to be exact when we're doing things like constructing a house. So there's different times we're going to need to be using addition and subtraction of decimals, and that's what we're going to be taking a look at today. To get us started off, what we're going to look at is a word problem. I'm going to put that on the screen, but don't worry about writing anything down. Just kind of take it in. Right after we look at the word problem, what we're going to solve, we're going to review what a decimal grid looks like and how we use it, and then we'll use that to solve our problem. So let's take a look at the problem. Wayne and Griffin are building a treehouse out of wood boards. Wayne has a board that is 1 15/100 of a meter long, and Griffin has a board that is 7/10 of a meter long. What is the combined length of their boards? Here we are now with a hundredths grid. Before we get started with the problem that we just saw, we're going to review how to use a hundredths grid and what it shows. So in looking at our hundredths grid, what does each individual box represent? Well, if you thought to yourself that each individual box represents 1/100th, you would be right, because there are 100 boxes in here to make one whole. So each little box is 1/100th of the whole part. Now if we look at this model again, what does each whole column represent? Looking at the grid, we see that there are 10 different columns going down. So each column represents 1/10 of the grid. Thinking back to each square being 1/100th, we write 1/100th as 0.01. And now, that's one little square. If we look at each column, that's 1/10. Each column, since it's 1/10, is 0.1. It's 1/10 of a whole. It would take us to fill in 10 complete columns to get to one. So that's how we would use a hundredth grid. And that's what we're going to look at with the problem. So we'll get a little more experience with that, but we just wanted to review that quickly before we actually demonstrated how to solve this problem. So let's go ahead and jump into our problem again. In your PBIL section, you have 2 hundredths grids that are sitting next to each other. Go ahead and flip to those if you're not there yet. We're going to use those to answer the word problem that we read just a little bit ago. When we use our hundredths grids, we're going to start with the greater number. So, if you remember, Wayne had a board that was 1.15 meters long, or 1 15/100ths of a meter long. So what we're going to do is fill in Wayne's board. So it is one whole board. So all of our squares, all of our hundredths are going to be filled in. There's one whole grid filled in. So there's one. And how many was left over? Well, there was 15/100ths. So if I remember right, there's 1 in the tenths and 5/100ths left over. So this now represents the length of Wayne's board, 1 15/100ths. Now how can we model the 7/10ths portion of this for Griffin's board? Well, for 7/10ths, we're going to have to fill in 70/100ths, right? Because 70/100ths is the same as 7/10ths. So I'm going to fill in 7 whole rows. So I'm going to fill in 5 of this first one. And then I'm going to fill in 1,
2, 3, 4, 5, 6. So we're at 6.5 right now. And remember, I need 7 full ones. We'll make this a little bit neater. Make sure that they're all filled in. Okay, so now we have 6.5 filled out, so that's 65 hundredths. But
I need 70 hundredths, or 7 tenths. And that represents how much Griffin had. Well, now all we have to do is look at our model. How many boxes are filled in on the first grid? Well, there's 100, it's all of them. And how many boxes are filled in on the second grid? Well, there's 85. What addition sentence can we use to show this model? Well, it's going to be 0.7 plus 1.15. So we can use that sentence to show this. And what is the sum of this? Well, we can just look at the grids and see that there is 1, and then there's 85 hundredths. So combined, we have 1. Oh, let's move you over a little bit. So combined, we have 1.85, or 1 85 hundredths of a meter long. When we're doing this problem without models, the important thing to remember is that we need to line up the decimals. And what that looks like is we're going to take 1.15 plus, and we'll change the color so you can see which colors we did, 1.15 plus 0.7. So if you notice, my values stayed lined up. If I wanted to, I could put the 0 in here to show that it's 70 hundredths or 7 tenths is the same thing. And now we just combine them. So 5 plus 0 is 5. 1 plus 7 is 8. Bring down my decimal, and then I bring down the 1. So our model just shows the exact same thing that we do when we line up the decimals. So that's just kind of giving you a visual and seeing how we can use models to demonstrate. Now what we're going to do is flip to our guided practice problem to do a few more examples. Meet me now in your guided practice section. So to start off this problem, here's what we're going to do. Copy down everything that I do, and you're just going to do it alongside with me. So number 1, we have 5 and 9 tenths plus 2 and 7 tenths. The first thing that I see when we do this is that we need to line up the decimals. So I'm going to rewrite it as 5, make sure we can see those, 5 and 9 tenths plus 2 and 7 tenths. Well, when we add our decimals, now that our place values are in line, we just add this like we normally would add numbers. So 9 plus 7 is 16. 5 plus 2 is 7, plus 1 is 8. So our answer there is just 8 6 tenths, or 8.6. Go ahead and copy down number 2 if you hadn't had the chance to yet. And once you copy that down, follow along with me. Again, we're going to line up the decimals. But this time, notice we have a subtraction sign. And that's not going to change anything. We're still going to subtract just like we normally would. So I cannot take 5 from 1, so we're going to have to borrow. And I can't borrow from 0, so we're going to have to go all the way to the 1's place. So now I have 10 minus 5, 9 minus 9. I bring down the decimal because it stays lined up. And 3 minus 2 is 1.05, or 1 5 hundredths. So those are your first 2 problems in the guided practice. Make sure that you have everything written down that I do, and then get ready for number 3 is going to try to throw us a little bit of a curveball, but I think you guys can handle it. So let's see what we have to do. Go ahead and copy down this problem. We have 10 plus 3 and 284 thousandths. There's a mosquito. 284 thousandths, or 3.284. So go ahead and make sure you have that written down, and we're going to solve this. To solve this problem, we're going to do it just like any old number. There's mosquitoes everywhere. We're going to do this just like any old number, right? So what I'm going to do is I'm going to write the number 10. And if you remember, the decimal is at the end of a whole number, right? It's just kind of a known thing. If I were to have 10, my decimal's technically right here, right? Then I could put 0, 0, 0, as long as I have a decimal at the end. So that's where my decimal is understood to be. Let's go ahead and get rid of this real fast. And now I'm going to line up my decimals. So if I pretend that I have a decimal here, to line up my decimals, I just add 3.284. And I have additions, I'm going to bring that down. If I wanted to, I could fill in zeros wherever I needed to. So I could put 10.000, and technically there's nothing in the tens place, so I can put a 0 there. So you can do that visually if it helps you. Otherwise, you can just know that there's nothing there and you don't need to add anything. So 0 plus 4 is 4. 0 plus 8 is 8. 0 plus 2 is 2. And I remember to bring down my decimal. 0 plus 3 is 3. And 1 plus 0 is 1. So even though it looks a little bit complicated, as long as you line up the decimal and remember that a whole number technically just has a decimal at the end of it, you'll be perfect and you just add like you've been doing since 1st or 2nd grade. So let's look at number 4 together and see if we can figure it out with subtraction. Here's number 4. If you can handle number 4, you can handle anything. So here we go. We have 15 minus 6 and 108 thousandths. So the first thing we need to do is line up the decimals. So when we line them up, we know that there's 15, and there's technically a decimal at the end of 15 if that helps us. And now we have to line up 6 and 108 thousandths. So we put the 6 in the ones because that's where it is, and we line them up and we have 1, 0, 8. Remember we have subtraction, so we're going to go ahead and bring that down as well. So it's 15 minus 6 and 108 thousandths. What I'm going to do for this one is I'm going to fill in the zeros just to help me out. So 0, 0, 0. So 15 and 0 thousandths is the same as 15, right? So now all we have to do is basic subtraction. Can we take 8 if we have nothing? No, so we're going to have to borrow. We're going to have to borrow. We're going to have to borrow until we get all the way to the ones place again. So I borrowed, and that made that 10, but I borrowed from that 10, and now we're at 9. I borrowed and made that 10, but we borrowed from that one, and I made that 9. So now, what's 10 minus 8? 2. What's 9 minus 0? 9. What's 9 minus 1? 8. We bring down our decimal to the same spot, it doesn't change. 4 minus 6, well we can't do that, so it's going to be a it's going to be 14, and we borrowed from the 1, it took it away. 14 minus 6 is going to be 8, and we bring down our 0 if we wanted to, so it's going to be 8 and 892 thousandths, or 8.892. So go ahead and make sure that you followed each step and that you lined up your decimals and got the same answer as me. Once you've done that, you can go ahead and take your quiz on Pearson. Email me your score, put it in the subject line, and I will see you in class tomorrow.
We're going on a mission. Start the countdown. 5.
Go ahead and meet me now in your guided practice section. Hi, Miss D. Yeah, I like to film myself sometimes, just a little something to watch me. I'm filming my lesson. It's awkward. Okay, so now flip to your guy. Dang it.